Okay, so the next speaker is going to be myself, and I have the challenge. So I'm actually the warm-up show to the talk of Elad Lavi, who will be talking about LLMs. And my challenge is to introduce transformers in 10 minutes. I have a PhD in applied math, and I'm a parallel entrepreneur in SagivTech, deep pathology, and surgeon eye, and hopefully more in the future in the field of medical applications, but that's it for now. Okay, so okay, so we are going to talk about 10 minutes intro to transformers, and not very long ago I gave like 4 hours on transformers, and I had to decide how to squeeze it into 10 minutes, and I hope I will be successful, and I hope you realize that it will only be. So please, someone take 10 minutes from now, because I tend to talk and never stop. Yossi, can you do that? Okay, thank you. So, okay. So, when we look on usual deep learning, classification, segmentation, etc., then we have, models that we train, and they give us some kind of result. When we look at the journey for transformation models, we look at, it starts with neural machine translation, taking text in one language and transferring it into another language. In order to do that, basically what we have, the basic structure would be of an encoder and decoder. So what we have is the encoder is actually a features extractor, and the features extractor actually takes word by word and produces some kind of a context vector. So we are actually squeezing all the information into some context vector. And from this context vector, this is like a common ground that we are using, but this context vector is actually used by the decoder to decode the information to actually whatever we like. And one of the use cases would be to translate it into another language. Now, one of the most basic structures in doing that, so looking at a problem where the input is reoccurring. So we have, in a sentence, we have word by word by word. And looking only 10 years back, we can look that nowadays we have like all chapters and all text generated by ChatGPT, but 10 years ago, the task was to really take and interpret only a single sentence. So what are recurrent neural networks? Recurrent neural networks are neural networks where we have an input, we have an output, but this is only part of the process. We then have a new input, a new output, but we also have a hidden state. And the hidden state is super important because it encompasses all the information so far. And in a sentence, we need context. And actually, this is exactly what we have. We have context, and this is how we can generate a whole sentence or a whole chapter, because context, as we all know, is super, super important. Now, context should be as wide as possible. And when we look at the LLM as tools available today, they have a very, very broad context. But again, 10 years ago, one of the limitations of RNNs was that they couldn't have a very large context. They could actually, I saw my daughter, this is why I was smiling. Hi, Mikey. So the context was very limited because of vanishing gradients. So this is why it was very limited, and you couldn't really look at whole paragraphs, but only small sentences, because the gradient vanishes when we were moving away from the starting point, so it really limited what we could do with typical RNNs. And then came to the rescue the LSTM, the long short-term memory networks, which are actually rooted much, much longer than AI has become so popular. And LSTM is, I will not go into the details, but they have the property of remembering. They have a forget gate, and they have an input gate, and that gate, and this gate. But what is important is that they have the capability to remember stuff for a long duration of time, and this is something that you can actually teach them. So the different memory blocks are called the cells, and it's a whole huge topic. And the important thing is that now you can have a much, much wider context. And then came the topic of attention. And I wasn't in the last GTC in like a few weeks ago, but Jensen Huang actually gathered together the authors of not of this paper, of the next paper, about transformers, because he said that many of the things available today can be traced to the concept of attention. And this is super important because it means, so you see this is a very famous name, Joshua Bengio, and what they said is that it's not enough to have context, you also have to understand what's important and what's not important, so where to put your attention. And so the relative importance of the words should be also taken into consideration. And I will not go into all of this. It's very, very interesting and fun, the embedding and everything. But the idea is that we have some kind of encoder that accounts for the order of the words, of how they are related to each other, onwards and backwards. And then you are creating some kind of an attention, let's say, a parameter, which would be some kind of an average of all the attentions of all the, let's say, the relationships between the different encoder parameters. And this was like a very, very important starting point, which culminated in the really, in this paper of attention is all you need. And this is the basic of transformers, because, well, maybe it's not all you need is love. This is Beatles in the 1960s. And nowadays it's attention. And I'm not sure that this is very, you can also take it into social meanings. So the key to the amazing performance of transformers is their ability to really relate every word in the input sequence to every other words. And there are three basic mechanisms. There is a base mechanism of self-attention. So imagine that you have the input sentence, the output sentence, and you look at the relationships between the words in the input sentence. So this is self-attention in the input, self-attention in the output, and also attention between the input and the output. So it's a very complicated and complex attention mechanism, which is, and of course I'm not going to go into all the details of that, but it's like, as I said, this is like the basic structure of how you are training a transformer. Now, attention started from LLMs, but then it also invaded the field of computer vision. And again, you see again the name of Joshua Bengio, one of the very, very early works on attention in computer vision was to generate captions to describe some kind of visual information. I think that this is now only growing, the connection between LLMs and computer vision. I'm not sure that I know where it can lead, but I guess that there's still a very, very long way to go. And I hope that this was a short introduction, a warm-up to Elad. And I'm not sure that you may have any questions, but if you do, I'll try to answer. I finished, if you